distance time graph review. With distance time graphs, we have the distance on the y-axis, and in this case it's in meters, and you have the time on the x-axis, which is in seconds. What can we find on the y-axis? What can we find on the x-axis? Looking at this race, the girls' bicycle race, we can see that over here using the key, Janine is the asterisk, that if we go to 20 seconds, Janine had traveled 40 meters in those 20 seconds. Please tell me how far Kathy traveled in 50 seconds. Please also tell me how long it took Melissa to travel 60 meters. Also, please tell me how far did Janine go in 10 seconds? And how long did it take Melissa to get to 40 meters? Using a distance time graph, we can then calculate speed. Please remember that speed is calculated by doing distance divided by time. So if we wanted to find the distance, the speed of, let's say, Melissa at 70 seconds, we would take her distance, which is 100 meters, and we would divide it by the time, which is 70 seconds over here. When I do 100 divided by 70, I get 1.428. The 2 is in the hundredths spot. The 8 afterwards tells me to round the 2 up to a 3, which would make it 1.43, and our label would be meters per seconds. Using your calculator, please find the speed of Melissa at 60 seconds. Also, please find the speed of Kathy at 30 seconds. Please note, to find the speed for Kathy at 30 seconds, you're going to have to realize that the open circle here line that is Kathy overlaps the line with Melissa. So this would be the same dot for Kathy at 30 seconds as it would be for Melissa. With distance time graphs, we can also understand and see where an object is not moving, which means it has zero acceleration. So for example, if I take Janine's line here, right here there is a horizontal line where my distance stays at 50 meters. However, my time moves from 30 to 40 seconds. So therefore there is no movement because of this horizontal line. Please tell me, when does Melissa experience zero acceleration? Another topic we have discussed is constant speed. For example, here if we follow Kathy's, constant speed is when the slope continues up at a steady pace, meaning it does not get higher, it does not get lower. It stays exactly the same. So here, Kathy would have constant speed from 40 seconds through 70 seconds. Please let me know, besides the same 40 to 70 seconds, when Janine also shows constant speed. Remember, there has to be at least 3 data points in order to show constant speed. 2 final concepts we have worked on is to notice when something is speeding up or when something is slowing down. If we take Melissa's line right here, we notice that if we continue this line straight through, that between 60 and 70 seconds, so from 50 to 60, this is the slope. If I would continue it on, we notice that the actual slope for Melissa between 60 and 70 seconds is steeper. It's closer to vertical, which would mean that she is speeding up. In the same case, if we take Melissa down here, between 0 and 10 seconds, and then if we look at 10 to 20. So if we would follow this slope from 0 to 10 seconds straight through, we notice that the slope that's actually there is more horizontal. Therefore, Melissa would be slowing down at that time. Therefore, if we look at Kathy, which is this open circle, what happens to Kathy's speed here between 10 and 20 seconds if we compare it to the speed back here between 0 and 10? So I want to know what this line is representing. Is Kathy speeding up or is she slowing down? Also, looking at Kathy, I'd like to know here between 40 and 50 seconds. So go back and compare between 30 and 40. But looking at 40 and 50, is Kathy speeding up or is she slowing down?